Hi, in this video, in our fifth part for quantum physics for the IB curriculum, I'm going to be looking at the Bainbridge mass spectrometer, which is used to measure the mass of subatomic particles and other particles. And in so doing, we're going to have to call on some of the things that we have studied previously. Now, it actually is in three different parts, which this diagram actually comes from your textbook, which I'm going to use. What actually happens is that this part S1, you have got charged particles that come through. So you have some sort of source of charged particles, and then this only allows a certain number, and these come in to S2. So what we basically know from here is the charge of these particles. We know what their charge is. Other than that, not much more. We want to, from this, find out what the mass of the particle is. Now, when they come into S2, this is an area where we have a magnetic field. It's drawn in here, this cross over here. So it's got a certain magnetic field, and I'm going to do it B double prime like that. And also there is an electric field. So there is an electric field. It could be going in that direction over there, something like that. So as these charged particles come in, they are affected by the electric field, and they are also affected by the magnetic field. And we set up the magnetic field that its force is in the opposite direction to the electric field. Now, our force, due to the electric field, is given by the electric field strength times the charge that we're dealing with. Actually, it may not be an electron. Let me just use Q for the moment, because we're not quite sure what the particle is. It could be an electron, it could be a proton, so E would then be appropriate. Now, we can work out E for parallel plates, as we got here, by V over D. And this is known in the experiment. This V and the D, the voltage across the plate and the separation of the plates, the D, would be known. So we can replace this by force is equal to V over D Q, like that. So we've got the force. Now, we have this force, and we also have a magnetic field force, a force due to the magnetic field. And we know that that force is given by Q V B. And we can actually equate those two. So we can have that this force is equal to this. If this goes straight through, then we would say that the force due to the electric field is equal to the force due to the magnetic field. The two are the same. So we can say that V, the voltage, divided by the distance, is equal to and times by Q is equal to the velocity times by B. And sorry, we also have a Q in here. That Q will actually cancel. So we get the voltage times by B divided by D is equal to the velocity. We know this, and we know that. And therefore, through S2, we can calculate the velocity. Now, this is velocity. Maybe I must write this velocity like that. We can know the velocity. So as it comes into the S3 part, as this charged particle comes into S part, we know what the velocity of that is. Alright, now I'm actually going to erase that all, because I'm going to need the space. Or maybe maybe I can work over here in this part over here. Now, when it comes into S3, we are going to arrange the magnetic field that it's going to work at right angles and inwards, so that the charged particle forms circular motion. We can adjust this B, and we can know what B is. So this B is something that is known, and from that we can actually work out the radius that the charged particle moved. So this radius here from that center, we can work that out. Now, we know that the force due to circular motion is given by mv squared over r. And that force is provided by the magnetic field, which is equal to QVB. Now, from that, we can do a bit of manipulation here. We know that this velocity and this velocity are the same, so we can cancel that. We can find what our m is. M is going to be QRB divided by V. And so from that we can actually work out what the mass of our charged particle is, because we know the charge. Remember, we said we know that. The radius we measure here. We measure the radius from this part of the apparatus. This is B prime. This is what we know. And we worked out the velocity from over here. So with that, you are able to work out or calculate by means of this apparatus the mass of the particle. So that is the Bainbridge mass spectrometer. Thank you very much.